Here's the formula for compound interest. I'm going to write the formula and then we're going to develop it. Now I'm going to write this as the future value. All right, this will be the amount that we have after so many payment periods. So the future value is found by taking the principal, the amount that you invest, and then multiplying by this quantity, 1 plus r over m raised to the mt. We'll do some examples, but first of all, we're going to derive this formula. So we're going to start here with, I'll do it up here. We're going to start here with p dollars, and now after one compounding, here's how much we're going to have. We're going to have p dollars plus the interest on that p dollars. So the interest is going to be p times, all right, I'm going to write I for the interest that we make off that. And now if you notice, you can factor a p out of here. So we're going to get this, p times 1 plus I. So let's start with doing this. I'm going to put, all right, times 0. Here's the first compounding, the second compounding, the third, the fourth, dot, 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 the nth compounding, just so I can keep track of these compoundings. Now, we're going to start here with p dollars. Now, after the first compounding, how much do we have? Well, we'll have our p dollars plus the interest. I'm just going to use an I for the interest per period on that. All right, so we'll have our original amount plus, right, like 5% of that original amount or whatever the percentage is. Now, notice that you can factor out with a little bit of algebra here. We can factor out that p getting 1 plus I. Now, starting the second period, how much money do we have to start with? Well, the amount we have to start with is this one right here, right? Because that's our ending amount after the first compounding. So this is going to be our amount to begin the second period. So we're going to start here with p times 1 plus I. We'll have that amount plus the interest on that amount. So p 1 plus I times the interest on that amount. And now factor, right? P times 1 plus I, p plus 1 times I is common to both those terms. So I'm going to factor that out. So we've got p times 1 plus I times, so what's left here? Well, I took a p1 plus I out of here, so there's a 1 left, and then I took this out, so there's an I left. So what's left is a 1 plus I, but then look at this, 1 plus I times 1 plus I, we'll have p times 1 plus I squared. All right, I'm going to run through that factorization again, just so you're sure you've got it. I think you know how it is, but it looks a little bit different than maybe what you're used to seeing. Look at this one right here. That's what we're going to factor. What's common to both terms? This term and this factor right here. I've got a p times 1 plus I here, a p times 1 plus I here. Now that's kind of like this, back in algebra. I'll do it right up here. What would you do if you had this? X plus xy. Well, you know what to do here. You've got an x in both those terms, so you're going to factor the x out. And now what goes back in here? Well, remember, this is really a 1x. So if you remove that x, what's left is a 1, plus remove that x, you get a y, and that's all I've done here. I've got this and this, remove the p times 1 plus I, remove it there, and what's left? Well, there's a 1. The 1 comes from here, right? There's one of those, and then plus, remove it, you got the I left. And then 1 plus I times 1 plus I is 1 plus I squared. Now let's start the third period. So the third period, how much money are we going to start with? Well, we're going to start over here, right? We've got, at the end of the second compounding, we've got that much money. We're going to start the third with that amount. So we're going to have p times 1 plus I squared. That's how much we start with. Plus, then through the third compounding period, we get interest on that. P times 1 plus I squared times I. Now you see this? What's common to both? P times 1 plus I squared, p times 1 plus I squared. So I'm going to factor out that p times 1 plus I squared, and what's left? 1 plus I. And then we've got 1 plus I squared times 1 plus I. So we're going to get out of here p times 1 plus I cubed. You see the pattern? So what do you think is for this one here? I think I'm not going to develop this one. This is going to be p times 1 plus I to the fourth, dot, dot, dot. And in general, is going to be p times 1 plus I to the nth power. But I'm going to change this around a little bit. So the amount, or if you like, the future value after n payment periods is going to be p times 1 plus I. But if you remember, the I is the interest rate per period. So we take the annual rate divided by the number of compoundings times raised to the n. Now n, that's the number of compound periods, the number of payment periods. That is m times t, right? M is the number of compoundings per year times the number of years. There's our formula. Let's run through a couple examples to make sure we know how to use this. So here's the first one. $6,000, all right, now that's deposited, so that's P, that's the principal, is deposited in a savings account at 6% interest compounded monthly. Find the balance after 3 years and the amount of interest earned during that time. All right, so what's our balance? What's the future value of that $6,000 in 3 years? So here's how I like to do these problems. I'm going to say this. Here's what I'm trying to do. I want to find the future value, and what I'm given is this. P is equal to 6,000. I'll do everything in thousands. So 6,000, let's see. We have that R is equal to 0.06. We're compounding monthly. That's M, the number of compoundings per year. That's 12. And N, all right, N, this is the number, well, I don't want N here. You know what I want? I want T. T is the number of years. All right, now I think I've almost got everything in here. Well, look at the formula. What do we need? P. Okay, I've got P. R. I've got R. M. I've got M. I've got M. I've got T. Okay, I've got everything in the formula that I need. Now let's just substitute in to our calculator and compute. So the future value of that $6,000 is going to be 6, or 6,000 if you like, 1 plus R, 0.06 over 12, right, 0.06 over 12, that's the interest per month, times M times 3, right? There's 12 payment periods per year times 3 years, so it's 36 payment periods. Okay, this is a calculator problem, or Wolfram Alpha problem. I'm going to put this in my calculator just like this. 6, then 1 plus 0.06 divided by 12 raised to the 12 times 3. And I'm getting that future value to be 7.18. Now this is in thousands, so I'm going to move this over 3. So the future value of that 6,000 turns out to be 7180. So we put in $6,000, and in 3 years, we're now at $7,180. There's the future value. And then what about the interest? Well, the interest is going to be the 7180 minus the 6,000. So how much did we make in interest? Well, we made $1,180 in interest. Let's do another example here. So it says $1,000 is deposited for 5 years in a savings account, or that $1,000, that's our principal. 5 years, that's T, in a savings account earning 3% interest. All right, R is equal to 3, compounded quarterly, M is 4. How much interest is earned during the 5th year? Oh, okay, so we just want the 5th year. Let's think of it this way. We are looking at a future value problem, so I'm going to start by writing the formula. P times 1 plus R over M to the MT. So there's the numbers that we're going to have here, right? I have P. Now P is the $1,000. R, that's 0.03, 3%. M, compounded quarterly, so 4 times a year. And what do we have? T, all right, we're leaving it for 5 years. So what we're going to have is the future value. Now this is going to be for after the entire 5 years. So I'm just going to put a sub 5 to remind me that's the amount of money we've made over the entire 5-year period. This is going to be 1,000 times 1 plus 0.03 over 4 raised to the 4 times 5. And I did this on my calculator, and I got 1161.18. All right, so in 5 years we accumulated, we turned $1,000 into $1,161. But now the question says, how much interest is earned just during the 5th year? All right, not all 5 years, right? During all 5 years, how much interest did we make? We put in 1,000, so the interest is right there. We made what? $161.18. What did we make just during the 5th year? That 161.18, that took us 5 years to accumulate that. What did we get in just the last year? So I think we can look at this problem this way. Let's take a look at what we made during the full 5 years, subtract off what we made during the first 4 years. So we already have this one, right? We have f sub 5, right? This is f sub 5. Now let's go ahead and find f sub 4, all right? So the future value after 4 years, that's going to be 1,000 times 1 plus 0.03 all over 4 raised to the 4 times 4, right, after 4 years now. So really, the only thing that changed was over here, right, the time, 5 years to 4 years. All right, so when I did that on my calculator, I got this, 1126.99. So the future value at the end of 4 years is 1126.99. So let's bring this back over here. What is this? I'm going to bring this back over here. So after 5 years, how much money do we have? After 5 years, we've got 116.1.18, and now let's subtract, after 4 years, 1126.99. I think that makes sense, right? And it took us 5 years to accumulate $161.18 in interest. After 4 years, we had accumulated $126.99 in interest. So in that 5th year, right, from year 4 to 5, how much did we get? Just make the subtraction. Well, I did that on my calculator, and I got, well, let's see if I can write it here. I got $34.19. All right, so in the 5th year, how much interest did we make? $34.19.